Let's take a look at this electricity question. So question 5 reads, circuit 1 and circuit 2 consist of a 12-volt battery connected to a 24-ohm resistor and a light bulb with a resistance of 16 ohms. We've given the diagram for circuit 1 and the diagram for circuit 2. We'll jump straight to question 5.2. Describe the arrangement of the resistor and light bulb in circuit 1. Now to figure this out, I'm going to use a highlighter to highlight the pathway that current will take. So current will flow out in one direction and it's going to reach this point. And it's at that point where the current is going to split. So it'll split here and it'll split here. Thereafter, it'll join back up and flow back through to our battery. So what we can understand here and what we need to remember is that whenever the current splits, the components that are connected there are going to be in parallel. So the answer to the question 5.2, they are connected in parallel. Question 5.3, for circuit 1, calculate the equivalent resistance. Now to calculate resistance in parallel, there is a formula, but I want to go ahead and use a shorter method. R parallel is equal to product divided by sum. Product being 24 times 16 divided by 24 plus 16. That's equal to 9.6 ohms. Now let's move on to question 5.3.2. For circuit 1, calculate the current that passes through the light bulb. So to answer the question, we're going to use Ohm's law. And the equation is I. So I'm going to write subscripts just to make it clear exactly what current I'm using. So I want to work out the current that's going through the light bulb. And so the light bulb has a resistance of 16 ohms. So the current through the 16 ohm resistor is going to equal the voltage through that 16 ohm resistor divided by the resistance of that 16 ohm resistor. Now, obviously, we know the resistance, so we're just going to be dividing it by 16 here. And the next thing is we need to figure out what's the voltage going to be for the 16 ohm resistor. Now, since they are all connected in parallel, this voltage would be 12 volts, and this one would also be 12 volts. Because remember that the voltage in parallel will be the same as long as there are no other components connected in series. So the answer here is going to be 12 over 16, which is 0.75 amperes. Okay, let's move on. Question 5.4. For circuit 2, calculate the total resistance. Now in circuit 2, there's no splitting of the current. And so it means that all the components are connected in series. So the resistance is going to be simply the sum of the resistors. So 16 plus 24, and that's 40 ohms. Now 5.4.2, the question reads, calculate the current passing through the light bulb. So again, we want to work out I through the 16 ohm resistor. That's going to equal the voltage of the 16 ohm resistor divided by the resistance of the 16 ohm resistor. And that's equal to something divided by 16. Now we have a problem because we don't know the voltage across the 16 ohm resistor, right? Now we could work it out, but it's going to be quite a long method, and for 2 marks, I don't think it's really necessary. Instead, what we could do and what we should do is that we should understand that the current is not changing. So the current, the total current, is going to be passing through the 16 ohm resistor and the 24 ohm resistor. So rather we should be calculating the total current in the circuit. So let's leave this out and say that the total current in the circuit, so I total, is going to equal V total divided by R total. So the total current in the circuit will be the total voltage, or the voltage in the battery, divided by the total resistance in the circuit. We know the voltage of the battery is 12, divided by, we know the total resistance of the circuit, we just worked it out, 40. So 12 divided by 40 is equal to 0.3 amperes. Let's move on to question 5.5. Calculate the charge, so Q, that passes through the light bulb in circuit 2 when the current flows for 2 minutes. Okay, now they've given us the time, 2 minutes. Though we can't use 2 minutes, we must use seconds. So 2 minutes is 120 seconds. And we worked out the current, so I is equal to 0.3. Now there is a formula that uses these three quantities and that we can use to work out Q. Remember the formula, I is equal to Q divided by T. So 0.3 is equal to Q divided by 120. Now you cross multiply, Q is going to equal 0.3 times 120, which is 36 coulombs. And now moving on to the last question, which is in which circuit, 1 or 2, will the light bulb shine the brightest? Justify your answer. So 5.6, it's going to shine brightest in circuit 1. So why circuit 1? Because remember, brightness is related to the current. Right? There are other things that obviously will affect brightness, but for this level, we'll just relate it to current. Now we can look at the current in circuit 1. We worked it out as 0.75. In circuit 2, it was 0.3. So the current in circuit 1, so the current through the bulb in circuit 1, is greater than the current through the bulb in circuit 2. And so the brightness is going to be more in circuit 1 than circuit 2. And that's it. Thanks so much for watching. Don't forget to like, share, and subscribe. I'll see you in the next video. Bye-bye.